Mineral dust can travel thousands of miles where it interacts throughout the Earth system. In our case, we're going to study how that mineral dust heats or cools planet Earth. Currently, we aren't sure whether mineral dust heats the planet or cools the planet.
We're looking at dust sources on the Earth's surface, so deserts, arid regions. Wind can basically emit that dust into the atmosphere. And so we are very interested in knowing what it is, and depending on what it is, it'll tell us whether or not it is warming or cooling our environment.
Some minerals are dark, maybe more red. They would absorb solar energy, and they could be heating elements. Other cases, minerals are bright white, and they could reflect sunlight back into space and cool the atmosphere.
And these desert dust plumes, once they get into the atmosphere, they are not small. If you look at some of the satellite imagery, you can see these huge desert dust plumes, larger than Spain, for example, coming across the North Atlantic.
So this is an important impact potentially on climate change looking into the future. As more lands become dust-forming regions, as they become desertified, we'll want to understand how those changes will affect our climate in the future.
This experiment is so important for us to understand what's going on at the surface of the Earth in terms of the mineralogy and the composition.
First, we're launched on a resupply service vehicle to the International Space Station. And once we're on the ISS, we would attach to the exterior of the space station. And I can't imagine a better platform than the International Space Station to measure Earth science.
EMIT is an imaging spectrometer, so it has a telescope which basically collects a lot of light, and we image all of that light onto the slit of what we call a spectrometer.
It measures light in many different wavelengths of the electromagnetic spectrum. Our eyes see 3 wavelengths, red, green, and blue, but EMIT sees in hundreds of wavelengths out into the infrared.
They give us signatures like fingerprints.
As we're traveling on the ISS, looking down at Earth, focusing on the spectral characteristics of minerals that are on the Earth. And so the imaging spectrometer allows us to detect those spectral signatures that tell us what type of mineral they're actually looking at.
This is setting a new benchmark for the quality of this class of instrumentation. This is just extraordinary.
It's really a convergence of state-of-the-art technology and state-of-the-art science so that we better understand the climate system and how it's responding to humans.